Let us take the next question, that is question number 4. Determine the instantaneous stress and deformation of a rod of 1 meter length and 6 mm diameter if a mass of 50 kg falls through a height of 10 cm and strikes the bottom of the rod. Assume capital E as 210 GPa. So here they have given the question. Based on this question, I will write the data and try to understand that out of the 3 conditions, which one is applicable here. Here we have to find the instantaneous stress and deformation of a rod. If a mass of 50 kg falls through a height, see here mass is falling through a height. So whenever the mass is falling through a height, then this becomes a case of impact loading. That is the third kind of load. So I will draw the diagram for this. So here we have a rod, and at the other end of the rod we have a collar. The length of this rod is given as 1 meter. Next, it is mentioned, determine the instantaneous stress and deformation. Stress and deformation, that is deflection, of a rod of 1 meter length and 6 mm in diameter. The diameter of this rod is 6 mm. Length, as we have written, 1 meter, that is 1000 mm. After this, if a mass of 50 kg falls through a height of 10 cm, here the mass is 50 kg and it is falling through a height of 10 cm, that is 100 mm. So small h is the height through which the load will be falling. So here we can see that we have a rod whose one end is fixed and the other is attached to the collar. On that collar a load is falling from a height. So easily, as looking into the diagram, we can say that this case is of impact loading. So the type of the problem is impact loading. Now we have to calculate value of stress and instantaneous deflection. So let us try to solve this problem. Solution. Since mass is given, I will be calculating weight. So I'll say that since weight W is equal to m into g, that is mass into acceleration due to gravity 9.81. So therefore weight comes out to be 490.5 Newton. This is the value of load which is falling from this height small h. Now we have to calculate stress for impact loading. So I'll use a formula that for impact loading, stress is given by, the formula I'll write it on the next page, that is stress for impact loading is load upon area plus square root of P upon A whole square plus 2 EPH upon area into length. So this is the formula for calculating instantaneous stress by impact loading. Now in this formula, as we see we even require area, I will keep this as equation number 1. And since cross section area is given by A is equal to pi by 4 into d square, which is 6 square, that gives me the area as 28.27 mm square. Next, all remaining values we have, so I can easily say that put all values in equation 1. So therefore stress is equal to load, we have found out 490.5 upon area is 28.27 plus square root of 490.5 upon 28.27 whole square plus 2 into Young's modulus is given in this question, that is 210 raised to 3. It is 210 actually, 210 GPa. So here I have Young's modulus is equal to 210 GPa, that is 210 into 10 raised to 3 Newton per millimeter square, into load, which is 490.5, H is given as 100 mm, area 28.27 multiplied by length is 1 meter, so it is 1000 mm. So from this I will be getting the answer of stress. Sigma is equal to, it is 871.17 Newton per mm square, our first answer. And the second question in this is to calculate instantaneous deflection. So I'll say that since instantaneous deflection delta L is equal to stress into L upon E, so therefore deflection is equal to stress is 871.17, length is 1000, Young's modulus is 210 into 10 raised to 3. If I calculate numerator divided by denominator, I will get my answer as 4.15 mm. That is the second answer. Hence we have calculated the value of stress and deflection, and with this the problem is completed.